So today we're going to be talking about section 3.6, which is the last section in chapter 3. Today we're going to be talking about perpendicular and distances and how they're related. Now, we know that if we have some random line here, what we can say is if there's some random point off here, off the line that isn't on the line, the distance from that point to our line actually is a perpendicular line, forms a 90-degree angle from that point to there, which we know to be true. We know that lines or points, the shortest distance between 2 points is a line, and we're actually finding basically the distance from this point right here, this random point, to a point on my graph, right? And it forms a straight perpendicular line there. Now, we could draw another line from that point to our line right there, but you'll notice that that line is longer. Also, if we did another line, we could do another one that's like over here. That one's even longer, right? So the shortest distance between those points, or the distance from that point to our line, is a perpendicular line, right? So, so it basically says this, that between any line, any line and a point not on that line, there creates a perpendicular, exactly one perpendicular to that line, which we know to be true. And so that's our postulate 3.6 that we're going to be using today. Now, let's look at a couple examples. The first one, it says, let's consider a line L that contains the points -5, 3, and 4, -6. Find the distance between line L and some point P, which is 2, 4. Well, I'm going to start by graphing my line. So -5, 3 is right there. And 4, -6 is going to be right there. And we can make a line right between those points. Okay, that's a pretty good line. Okay, right there. Then we're asked to find what the distance is from that point right there, 2, 4, and that's point P. So essentially what we're going to do is we are going to find the equation of line L. Okay, we're going to find the equation of this line right here. And then what we're going to do is, knowing that since we have to form a perpendicular line between it, okay, some perpendicular line between point P, we can find that line, the equation of that line, set them equal to each other, because where they're equal to each other is their point of intersection, which is right there. And our job then is to find the distance from point P to this purple point right here, which we can maybe see what it is, but I think we'll use our equations to be even more precise. Okay, so the first thing we're asked to do basically, or the first thing we have to do for this problem, is to find the equation of line L. Okay, so let's do that. So line L, the first thing I need to find is the slope. Anytime I'm finding equation of a line, I need to know the slope between them, right? So our slope is going to be, well, if this is x1, y1, and this is x2, y2, the equation of our slope is going to be -6 minus 3 on top, and it's going to be 4 minus -5 on the bottom, which ends up becoming, when I subtract them, -9 over 9, which is -1. So the slope of line L is -1. Now that we know a slope, and we can actually use our point x1, y1 in point slope form, we can figure out the equation of our line. So that's going to be y minus, y1 is 3, and m is -1 times the quantity x minus a -5. Okay? Just like we did before in all of our examples, we distribute the -1. We get y minus 3 is equal to -x minus 5, or -1x minus, it's all the same thing. And then we add 3, and we find the equation of line L to be y equals -x minus 2, which if you look right there, it kind of looks like it's -2 right there. That's where it crosses the y-axis. Okay, so that's the equation of line L. So now that we know the equation of line L, we can find the equation of a line that's perpendicular to line L, which is going to have an opposite slope. So our new slope is going to be opposite. So instead of negative, it's going to be positive. And instead of 1 over 1 or 9 over 9 or whatever, you're going to flip it, and it'll just be +1. So that's the equation of our new slope, +1. And we have a point P, which we'll say is x1, y1. And we're going to use that to find the equation of our new line. Okay? the line containing point P. So we'll say y minus 4 is equal to 1 times the quantity x minus 2. I distribute my 1, which is easy, it's just 1, and I get y minus 4 is equal to x minus 2. I add 4, and I find the equation of this line to be y equals positive x plus 2, which I guess if we do our point a little bit bigger, it does look like it crosses at 2. So now we have the equation of two lines, right? So our job now that we have the equation of these two lines is to find their point of intersection. Where do those two lines meet? And so how we find a point of intersection, back if we looked, if you think back to earlier when we had systems of equations, what we did is we set them equal to each other. And we said negative x minus 2 would be equal to x plus 2. Because where they're equal is the value of x and the value of y where the 2 points will intersect. So this is a moron problem, basically, and there's more x's on the right, so I'm going to add 1x to both sides. I get negative 2 is equal to 2x plus 2. I subtract 2, and I get negative 4 is equal to 2x. So x would be negative 2, okay, which if we look at our point, that purple point right there, it looks like it's when x is negative 2. But if we know that x is negative 2, what's y going to be? Well, I can use either one of my points. And so if you look right here at the green line that we found, if I let x be negative 2, y equals negative 2 plus 2, which is 0. So y equals 0. So our point of intersection is now this point right here. It's got to be like that. Negative 2, 0. Okay? So we found a point of intersection. We found where the two lines meet. They meet at the point negative 2, 0. So, okay, so let's recap so far. So first part, we found the equation of line L. Then we found the equation from the slope, the perpendicular slope of a line that's perpendicular to L and containing point P. Once we did that, we set the two lines equal to each other. Once they're equal to each other, we can solve them out to find their point of intersection. That's where we're at now. So basically it's saying I have a line that's perpendicular to line L, and it contains the points 2, 4, and it contains the point negative 2, 0. Okay? So my job now is to find the distance between those two, right? And we have to think back to the distance formula. And in case you don't remember it, that's okay. Here it is again for you. x2 minus x1 squared plus y2 minus y1 squared. So we're going to use our 2 points. Let's say that this is x1, y1, and this is x2, y2. We're going to use those points in the distance formula to find the distance from P to that line. Okay, so let's do this. So x2 is negative 2 minus x1 is negative minus 2. So negative 2 minus 2 plus y2 is 0 minus 4 squared. Okay, so by simplifying, scroll down just a little bit here. Okay, by simplifying just a little bit, we see that negative 2 minus 2 is, that's negative 4 squared plus negative 4 squared, which, when we simplify a little bit further, let's see, negative 4 squared is 16 plus 16. And so the distance between these two is going to be, our distance is going to be the square root of 32. So going back to the original question, what is the distance between point P and some line L, and it contains those points? And so the answer to that, the distance between those, is the square root of 32, which you could go on a calculator. In fact, mine's right here. Do the square root of 32. It's 5.6 well, let's say 5.7 units. So approximately 5.7 units. Okay. So again, to recap, we find the equation of our line L that they give us. We find that point P. We find the line using the slope of a perpendicular line through that point. We find the point of intersection. And we find the distance between those, and we find the distance between the point P and our line L.